Hi, everyone. Thanks for joining us today. We're going to give people a few minutes to join, so just hang tight as we are getting ready to get started. A reminder, today's webinar is about better open source scaling and right size and K8s. We are joining us today is Andy Suderman, CTO, and Stevie Caldwell, lead site reliability engineer, both with Fairwinds. So we'll just give everyone a few minutes to join so that way we can get started here in just a moment. Wonderful. See a few folks joining us. A few of our different platforms. Wonderful. Great. I'll go ahead and get started right now. I'm Katie Greenlee, and I'll be moderating today's webinar. I'm going to read our code of conduct, and then we'll hand it over to Andy Suderman and Stevie Caldwell from Fairwinds. A few housekeeping items before we get started. During the webinar, you're not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there, and we'll get to as many as we can at the end. This is an official webinar of the CNCF, and as such, it is subject to the CNCF Code of Conduct. Please do not do anything in the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all your fellow participants and your presenters. Please note that the recording and slides will be posted later today on the CNCF online programs page at community.cncf.io under online programs. They are also available via your registration link, and recording will also be available on our online programs YouTube playlist. With that, I will hand it over to Andy and Stevie to kick off today's presentation.
Thank you. I'm going to share my screen so that we can share these amazing slides I created. Let's see. All right, we good?
Yeah.
Cool. All
right. Well, I'll kick things off. So we're here today to talk about better open source scaling and right sizing in Kubernetes. First, let's talk a little bit about who we are. So I'm Andy. I'm the CTO at Fairwinds. I've been with the company about 6 years. I've been running Kubernetes in various production environments for about 8. We run Kubernetes clusters for other people. So that's where we get all this information, and we use all of this stuff on a day-to-day basis. Running infrastructure for a lot of different customers across a lot of different verticals and a lot of different size companies. And I will hand it off to Stevie to introduce herself.
So I'm Stevie Caldwell, and I'm a tech lead for the SRE team here at Fairwinds. I've been at Fairwinds for about 5 years, so came in the door shortly after Andy. And I've been working in tech in general for as long as I can remember. Lots of previous lives as network admin, sysadmin, help desk person. And for the last few years, I've been focused primarily in container spaces and Kubernetes in particular.
Awesome. So a lot of what we talk about these days is about platform engineering. And I think that's one of those terms that we like to throw around in various circles and mediums and whatnot. And so I always like to start with a foundation of what do we think of as platform engineering? What do we call a platform? What is it that we deliver to our customers that's built on top of Kubernetes? So some people refer to a platform as an internal developer platform, but really the goal is developer enablement. We want to create a place for developers to be able to build and deploy their applications in a way that's consistent, safe, and ideally quick. One of the things we talk a lot about is how quickly can we get new features out? How fast can we deploy and stuff like that? And so Kubernetes by itself is not necessarily a platform, but the foundation for a platform. And so a lot of the content that we make and a lot of things that we talk about are about things that we build on top of Kubernetes, or we install and run and configure on top of Kubernetes to enable developers and platform engineers and DevOps engineers and all the myriad of titles that work on this stuff to run their applications in production on top of Kubernetes. And so today we're talking about right-sizing and auto-scaling. And Stevie's going to get into that a little bit more. But again, that's one of the pieces that we deliver as part of the platform that we give to our customers for them to run their applications, again, securely, safely, and deploy rapidly. So I'm going to hand it off to Stevie to talk about KEDA and all the fun things that we can do with autoscaling.
Yeah, thanks, Andy. I did have a quick question for you before I get started. What do you call an iPhone that isn't kidding around?
iPhone that isn't kidding around. I don't know. What do you call an iPhone that isn't kidding around?
Dead serious.
All right.
Yeah, that's a good one.
That's good.
So now everyone's relaxed and feeling good. So we're going to talk about auto-scaling first of all. I like to typically start off my webinars level setting, not making assumptions about what people know, because I feel like that tends to make a better experience for everybody. If you know this, there's no harm in hearing it again. If you don't know it, then it brings you up to speed so that you get more enjoyment out of what we're talking about here today. So what is auto-scaling? I went searching around online and I found a definition that seems decent, right? So auto-scaling, also referred to as auto-scaling, and sometimes automatic scaling, is a cloud computing technique for dynamically allocating computational resources. It's a mouthful, like most of our tech definitions are. Also, Andy, I'm full screen, so if you're trying to ever say something, I can't see you, so just jump in, okay?
Will do.
All right.
I'm surprised there's not an acronym in that sentence, though, because there's one thing that it's missing. Anyway, go on.
So that's a really wordy way of describing auto-scaling. I think in a nutshell, right, auto-scaling is adjusting your compute resources, in response to some threshold, some trigger, some desired state at its core. It's something that informs our systems that we need more or less compute, and then something does that for us. So I was working on these slides, and I said, Andy, can you come take a look at them? And he was looking at the slides, and he said, "What's with the burger?" So I have this burger here because I was both hungry and I was thinking about auto-scaling, and it occurred to me that one of my favorite places to get burgers, I think, is kind of a cool example of auto-scaling. So bear with me, ride with me here. Right. So this is a Five Guys burger. Five Guys is a burger chain, if you're not familiar with it, right? And when you walk into a Five Guys, what will often happen is the person at the register will turn around and yell 2 patties to the people cooking in the back. So you've just walked in the door, you haven't talked to anybody, and they've already put 2 patties on the grill for you. So by the time you get up to the register, place your order, pay for your food, get your receipt, step off to the side to wait, your patties are that much closer to being ready to, be slid into the bun and in your hand. And that, to me, is kind of like auto-scaling, right? Where the cashier is the loop, the thing that watches for, some threshold, some event, some change. Me walking through the door is that change, is that event. And then, having the cooks throw down 2 patties, that's the auto-scaling, the reaction, the action to the event. So
I like it.
I thought that was really cool.
I've never actually been in a Five Guys, but that makes a lot more sense having a burger on this slide.
Right.
And now I'm hungry. Thank you.
Now you're hungry, yeah, because it is a good-looking burger.
Right.
So there are many different types of autoscaling. In this space that we're in, containerization, specifically Kubernetes, when we talk about autoscaling, we're typically talking about one of these three types, right? So there's vertical pod autoscaling, which is where you're increasing the CPU or memory request of the existing pods. To keep with the Five Guys analogy, that is making bigger burgers that you put on the grill.
Instead of two patties, we make one really big patty.
One really big patty.
Yeah.
For horizontal pod autoscaler, it increases the number of pods to increase compute, right? So that is the putting more and more patties on the grill. And then for cluster autoscaler, that increases the number of nodes, which also increases compute and often plays into increasing the number of pods or the CPU or memory requests, because you might need more underlying compute to actually accommodate those changes, right? And that could be equated to adding another grill to the restaurant, right?
You might need another grill cook to work that grill, but yes.
Yes. Unless you're Squidward or SpongeBob, maybe. Squidward or SpongeBob. So those are the different types of autoscaling, just to give you a high overview of things. And today we're really going to be focusing in on horizontal pod autoscaler when we talk about autoscaling and right-sizing in your cluster. So what is the horizontal pod autoscaler? So it consists of two main parts, right? So there's a controller, which is a control loop that runs every 15 seconds by default, I think, and does a thing every 15 seconds, evaluates some stuff and does some stuff. And then there's HPA resource, which tells the controller, which configures what the controller is going to do, what it's looking to affect, and configures it, right? Over here, we have like a little snippet from an HPA resource configuration, and it has the spec field, which is if you've looked at any YAML for Kubernetes, this should be very familiar to you. And the various fields of this spec, right? We have max replicas and min replicas, which tells the controller, like it gives it guardrails for the scale parameters, right? So always have no fewer than 3 replicas running in this cluster, and you can scale up to 100, right? And then here is the scale target ref. And the scale target ref tells the controller what underlying pods to pay attention to. And it does this by using these selector labels on the deployment to find the associated pods. So it will find the pods that are owned by this basic demo deployment in our example here. And then the metric is the metric that we're keeping an eye on, and the one that's going to determine whether or not this controller actually does anything, right? So this metric we're looking at here is a very basic metric, and this whole spec is super basic. And it scales off of a metric type called a resource metric, which is CPU or memory, really, right? Mm-hmm. And it's pretty, I think, you can probably infer what this means from here. Average utilization, 30%. So it's going to, in a nutshell, look for all the pods, find out the CPU utilization for all these pods, average those out, and figure out if the average utilization across those pods is 30% or more. And if it is, then it's going to take some action, and it's going to scale up in accordance with that, right?
Yep. Question for you. So that utilization percentage,
yeah,
what is that a percentage of? Is it like how what do we say utilization is? What's like, is it the resource? Is it the CPU limit? Is it the CPU request? Is it, which one are we?
It's the actual like current usage of the CPU,
Gotcha.
of the container rather, in the pod.
Okay.
And yeah.
Cool.
So let's see. So it, but that's a good question, because if we're talking about, what this utilization is, that leads to the next part, which is where does it get this information? So we're talking about average utilization, and its average utilization across all the containers that are inside those pods. Where is it getting that information? And that's where the metric server comes into play. And as you see in this, it says it requires a metric server, which it does, because the metric server exposes metrics for these workloads in a way that the HPA controller can see, can access and use to make its scaling decisions. And so the metric server exposes metrics at the metrics.k8s.io API endpoint in the API server. And this diagram kind of gives you an idea of how that works. We won't go into too much detail, but CAdvisor runs on all the nodes. It collects metrics at the container level, exposes those metrics through the kubelet API. Metric server aggregates those metrics from all the kubelets in the node and then makes them available at metrics.k8s.io. And I'm going to pause out of here for a moment and go over to my cluster just to show you a little bit of what I'm talking about. So I also get super butterfingery when I'm doing webinars. So I copy paste a lot of my commands. Otherwise, we'll be here all day watching me.
We are still only seeing the slides.
Oh, you're only seeing the slides? Uh-oh. Hold on. Stop sharing.
While you're switching, I'm going to answer a question that came in from the audience, if that's all right.
Yeah, do it.
So we have a question about how HPA and Argo CD work together. I assume that once HPA changes the number of replicas, Argo CD will change it back to what it was in the first place. Any idea how to approach that? This is a really common problem when running HPAs on your deployments. So you can deploy a deployment spec without a replica count. If you do this, if you leave out the replicas field in your deployment spec, Kubernetes will assume 1, but it will also then defer to letting the HPA set the desired replicas. And so you don't have to specify it in your YAML. And this actually goes for any deployment system, not just Argo CD. If I'm using an HPA with my deployment, I want to omit the replicas field from my deployment YAML so that when I do a deploy or when Argo CD syncs, I'm not overriding the desired replicas of that HPA. We've actually seen behavior where you have a deployment that's being scaled up by an HPA. It's scaled to, say, 20 pods. You redeploy that YAML that where you've specified replicas 1, and it will immediately jump down to 1 replica and then jump back up to 30 because the HPA will take back over. And so you really want to avoid that situation by omitting the replicas from your deployment YAML whenever you're using an HPA. Very common issue, easy to fall into that.
Yeah. It's a good question. Can you see my terminal now?
I cannot. I think the host might need to add screen share back.
It's fine. I will just share the tab specifically. All right. How about that?
Oh, now we've got your terminal.
Okay, great. So I'll just have to go in and out when I switch back and forth, and that's fine. We'll just be a slight pause. All right. So I wanted to show what that metrics endpoint that metrics server is serving looks like. So this cube control command can be, if you pass in the --raw flag, in case you didn't know, you can access API paths directly, which I think is pretty neat. So if I watch, I knew it. I should have done that before. I knew that was going to happen. All right. There. Okay, so if I hit that endpoint, you can see here it lists all these metrics. So every container, every pod that's running in the cluster, it has metrics for every container within that pod, right? So this is what it's using, or what it's scraping. This is what metric server is making available to the HPA in order for it to make its scaling decisions. So we're going to go into this basic demo. We're going to show how HPA works, right? So we're going to go into this basic demo namespace, and we're going to see what we have in here, which is essentially, if this is working, yep. All right, so we have a deployment called basic demo, where I have set replicas to 2, and so it's running 2 pods. And it has a service. It's of type cluster IP, right? So it's just a generic demo site, and I think I have it set up as an ingress. So I'm gonna go ahead and copy that. Oh wait, that's gonna be a problem. I need to switch back to my window. I need to switch back to my. Sorry, y'all. All right, let's try going over here. All right, I just wanted to show you the demo app. Can you see this tab?
Indeed.
Okay, great.
I can.
Right. So this is just the basic Kubernetes demo. There are 2 pods running. Nothing super special. I've got my website going. Nobody knows who I am. No one ever comes to it. So, running 2 replicas of this are totally fine. It is a totally fine thing to do, right? And then one day, I have an incident at Five Guys, and next thing I know, I've gone viral. Everyone's going to my website because they want to know more about me, and I've only got 2 pods running, and pretty quickly, I will either cash out on CPU or memory, so I'll either start being throttled or, I'll get killed, and that's a bad experience for my newfound fame. So I want to scale up. Now, one thing you could do, obviously, and this is the way things were for a while, you go and you can run a scale deploy basic demo, and set the number of replicas to something and scale up, right? But this is kind of guesswork, and it's not particularly quick, right? If you're trying to do this in a reasonable, smart way, you're going to want to look at metrics, you want to look at your graphs and stuff and make a guess about what you need. And it's, by the time that happens, your window of fame is over, right? So you want to move a little more quickly than that. And HPAs are super easy to deploy the way that I've shown it so far, right? So you can literally copy paste this command over here, and you can run this cube control autoscale command. And if we do that, what we'll see is that an HPA has been created referencing the basic demo deployment. We can take a look at it in detail, take a look at the YAML, right? You can see the status of it, what the last recommended action was. You can see the resource. This should look very familiar because we just saw this in my slides, right? So average utilization at 30%, we're going to scale up, and but we're going to keep min replicas so at 2. So at any given time, we're just going to keep running 2 of these pods. But if now that I'm famous and people are starting to come to my website, it will scale up accordingly under pressure, like if it comes under CPU pressure. So if we do get pods, right, and we watch, and I have K6 running over here.
Nice.
I'm pretty sure that I'm running the right, yeah. Right, so if we run K6, we're gonna hit this with some traffic. And I'm doing a watch on the pods. I am not fancy like you, Andy. I could not make myself work with
Tmux.
Yeah.
It's okay. It's fine. Can we do a kubectl get pods, HPA and watch that?
Mm-hmm.
I'd be curious to see the metric changing or not. I don't use the dash much.
You do that. Yeah.
Oh, yep. So we're 100% CPU utilization now.
Yep. And as you can see, we've spun up 2 more pods. And if we keep going, I think we're going to see a lot more pods being created. And so, you know, I have been able to run to my computer, tippity tap my little command there, and I'm scaling up, right? Now there are obviously more pieces to this, right? Like as your container, like we were talking about all the other scaling and specifically cluster auto scaling. And as you create more of these pods, you know, they have to have a place to live and you might run into some problems there. That's a topic for another time. But, you know, at its very basic level, you get a number of pods that are spinning up that will hopefully help your workload deal with the increased load, right? Mm-hmm. And that's done. And so what'll happen is there's a certain amount of time that these will sit around here. Like, you know, see, there's a bunch of them. There's a certain amount of time that they'll sit around, and then the HPA will start to scale them back down once that threshold, once it determines based on the metrics that it has available to it in that metrics endpoint. And, you know, your scaling rules, it'll start to scale down and eventually get back down to, you know, 2 pods, right? Once my moment of fame is over, then, you know, traffic will drop and people will stop coming to my website. The default is that there's like a 5-minute window. I left it at that. So it'll be a while before we see those pods start to drop. But that is essentially, right, the horizontal pod autoscaler in a nutshell, right? That's super simple to use and super simple to deploy. Like I was able to deal with my sudden fame with no problem, right?
We're going to need to see a YouTube video of this 5 guys incident. By the audience is requesting it. So I'm definitely going to need to see that.
So given how easy and simple this is, one might ask, why do we need anything else? Why do we need something like a KEDA? Well, that's because HPA does have some limitations. One of the limitations is that it can be complex to set up other metrics, right? So the spec that we looked at was a very basic, you know, scaling on CPU and you can scale on memory. But what if you want to scale on something else, right? What if you have apps deployed in your cluster that you made, which I'm sure you do, right? That you've instrumented to be scraped by Prometheus. And you want to use those metrics to scale your app, or you're, you know, talking to a queue that lives outside of your cluster, like Amazon SQS or something, right? And you want to scale on the number of messages in your queue. It's doable, but it's not particularly easy, and it can be it's a little complicated to set up, right? So in the API server, there are 2 additional metrics endpoints, custom metrics endpoint and an external metrics endpoint that you can register a metrics server to use, right? And expose metrics at those endpoints in the API server. They require what's called a metric adapter. And metric adapters are provided by usually provided by the thing that is providing your metrics, right? And they are a bridge between the source of your metrics and the API server. We talked about metric server, and it is a bridge of sorts as well. And then these external metric or these metric adapters are also bridges that do the same thing. Prometheus has a metrics adapter that is an additional, installation. Datadog, which we use as well internally, has a metrics adapter that is built in, I think, to one of the to the agent, and you have to register those adapters with the API server. And this diagram down here kind of gives you an overview of like some of the pieces that you have to deal with if you're trying to do something as simple as use your metrics from your app, like we have in this example of an HPA spec that uses an external metric. If you're doing something as simple as trying to get your metrics in for autoscaling, in addition to your typical deployment and the pods that, again, you've instrumented at the /metrics endpoint that Prometheus is scraping, you also have to configure your metric in the Prometheus. You have to install the Prometheus adapter, and then you have to configure the adapter with your custom metric so that it's available for Kubernetes in the API server.
That's the part that I find particularly difficult with this setup, is that in the adapter, you have to write the query to create the metric as part of the configuration for the adapter. Right. And then you write your HPA to reference that metric. So you have to modify configuration in two different places just to scale on any Prometheus query.
Exactly.
Right? And I can write a Prometheus query in 5 minutes, but now I have to go put it in 3 different places. And anyway.
Right. Yeah. Right. Yeah. That makes no sense. And I wasn't like, I'd never tried to use the Prometheus to scale, do custom metrics. And I was like, that can't be true. Like the metrics are right there. They're in Prometheus. Right. Why do I need to like repeat that process with another add-on? That's silly. But it's what you have to do in the Prometheus adapter is that bridge. It sits at the custom metrics API endpoint, and horizontal pod autoscaler knows that it can look there for those metrics for an external metric type, right? So you can set Prometheus up, and that works for like custom, and you can set up an adapter, like say, for example, for Datadog, right? And that would use the external metrics API. The difference between custom and external is truly just the source. Custom metrics still come from inside your cluster, and external metrics are typically from outside your cluster, right? So you have Prometheus sitting at the custom metrics API endpoint, serving up your app metrics. You've got Datadog sitting outside. And then what if you have something else that you want to get metrics for outside your cluster? Right?
Now I've got to get that metric into either Datadog or Prometheus, and then go through the other 3 steps we just talked about.
That's right. Yeah. And you can only have one metric server. And so another limitation of HPA is that you can only have one metric server serving the external metrics API at a time. So you kind of have to even decide in some cases where you want your metrics to come from. So that's a limitation of HPA. HPA is limited in the objects that it can scale. So I think by default with resource metrics, it can scale on deployments and stateful sets, not daemon sets. And HPAs can't scale to 0. So if you have workloads that you're just like, I know I don't need these pods to be running all the time, you still have to run like a minimum of 1. That's the default if you're scaling off resource metrics in HPA. So that's why we have KEDA, which bridges some of these gaps or fills some of these gaps, and extends HPA. Honestly, when I first was learning about KEDA, I thought that it was a replacement for horizontal pod autoscaler. I didn't realize that it worked in concert with it to do its job, which is pretty cool. So KEDA is a CNCF project, and it was developed, I think, by Red Hat and Microsoft, I want to say.
I don't actually
It stands,
know.
huh?
I don't actually know. Anyway.
It stands for Kubernetes Event-Driven Architecture, right? So the basic high-level pieces of KEDA, and I'll drop into other I'll drop into other windows to show some of these things. But we have the scaler, which is responsible for fetching metrics. So the scaler can talk to an external source of metrics, and we'll look at what those scalers look like and how you implement them. But they're either built, there's a bunch that are built into KEDA. You can also make your own. But they fetch metrics from an external source. They also watch that external source, constantly for those metrics. And then based on a trigger, or based on some event that you describe, that you configure, it will then send the metrics to its internal metrics adapter. So there's a metrics adapter involved here as well that's registered at the custom metrics API endpoint. And it will put those metrics there. And then the controller or operator is responsible for bringing the workload up to the desired state based on the trigger and the metrics. And there's actually a thing that I learned that's pretty cool that I'll show, that we'll go in a little bit more into detail if we have time when we look at a scaled object reference. Is that KEDA does its scaling in like two phases, actually. There's a phase where it controls scaling, and then it hands it off to the HPA to do further scaling. So those are the basic elements behind KEDA operation. When you install KEDA in your cluster, it installs CRDs. Trigger authentication and cluster trigger authentication are CRDs that provide objects that allow you to set up authentication to your external trigger, to your external sources. And the difference between the two is the same as like cluster role binding and role binding. One is namespaced and the other is available across all namespaces. And then there are scaled objects and scaled jobs, which are resources that you define that tell KEDA how to create an HPA. Because under the hood, that's what KEDA is doing. Essentially, it is getting these metrics and then creating an HPA based on your definition, and then getting metrics and watching the source that you defined in your HPA and helping the horizontal pod autoscaler scale. Let's look at real quick. So first we'll look at scalers, right? So over on KEDA site, there are 64 scalers available just built in out of the box, right? So there are all these scalers, and each one of these defines the ways.
We are still seeing your slide.
No, I don't know what's wrong. Let me go over to this other page.
Screen sharing will be the end of it all.
I know it.
Forget AI. It's going to be screen sharing.
Screen sharing.
All right.
Curse you, screen sharing. All right, so here's the KEDA scalers page. So like I said, there's 64 available. And all of these define the parameters that you use to both watch and interact and get events and data from the source, and how you authenticate with the source. This is an unfortunate thing that I have to keep doing here. I would have made this so dynamic if I'd known. All right. So here's an example of a scaled object spec. I would have gone back and forth between them, but that's going to be a pain. So we'll just look at this. So this is a Prometheus scaler, and Prometheus scaler is defined on that page that I showed you. And so these are just some of the triggers that the Prometheus scaler makes available. Activation threshold and threshold. So this is actually related to the different scaling stages that I was referring to earlier. Activation threshold tells you what threshold the metric has to be at for KEDA to do what's called activating the scaler, where it will scale from 0 to 1 or back. And then threshold is the scaling threshold, and that's the threshold at which it will then hand control over to the HPA and have the HPA continue doing its scaling based on its configuration, which again came from KEDA. So we have like a metric name and a query, the server address for Prometheus, I feel like I'm running out of time, so I want to pop over to my terminal real quick and show
While you're pulling that up, I'm going to answer a quick question from the audience asking about, does KEDA support cluster autoscaling? Does it increase and decrease the number of, this says clusters, I'm guessing you mean nodes here based on the defined metrics, and the answer is no. KEDA is specifically focused on workload scaling, not on cluster autoscaling. And you really need both. You need a cluster autoscaler, and then you need to scale your workloads, and those should work somewhat in conjunction.
Okay, so real quick, I have until 1:45. Is that it?
I thought we had till the hour.
Oh, and do we have till the hour? Okay, then maybe I don't have to rush through so much.
Yeah.
Great. All right. So I'm over my terminal. You can see that, right?
Yep.
Awesome. All right. So what I've done, we looked at HPA and how that works with the basic demo app. I have another app called Boutique that I've installed here. You have to take my word for it that it works, because I'm not about to stop sharing and go back over to my browser. But it's there. It is an app. It's a web app that, you get online, developed by Google, I think. And here are all the pieces that are running. It's just a basic web app, and it shows a shop, right?
Basic web app with 10 services.
With 10 services.
Very basic.
Very basic. These days it feels like that's basic, but yeah, I get your point. So of particular interest to us is this deployment front end, which is what provides the UI for this fake website, right? So we're going to see what it looks like to use KEDA to scale up our front end deployment instead of using HPA, right? So like I said, this is my deployment, and I have here locally a KEDA object called Boutique Scaled. So first, let me actually just show you the CRDs that are installed in my cluster because I installed KEDA. So there's trigger authentication, which in cluster through trigger authentications, which we touched on in that slide. Scaled objects and scaled jobs. I actually didn't touch on scaled jobs. The scaled jobs are it's just essentially what it sounds like. Instead of scaling pods that are sort of long-lived until you no longer need them, it scales your workloads as a job, and your job will pull a message off of a queue, run, process it, and then go away. So it's supposed to be particularly good for workloads that have long-running tasks involved.
Long-running tasks that end is the key, right? But yeah, it's great for doing queue processing.
Okay. And this one, have you used this Cloud Event Sources SN Super Alpha, I think?
I have not. I don't even know what that is.
Okay. So that's a CRD, but we don't have to, we're not focusing on that, because what we're going to focus on is HTTP scaled objects. So we talked about scaled objects, and that I think, we covered that pretty well. And I was going to show a demo using Prometheus as a scaler. Prometheus and I had a fight. And I decided that rather than continue that unhealthy relationship, I was going to pivot to another CRD that is very similar, because ultimately you just want to see what this looks like, right? So forget Prometheus. I don't know you. So this is an HTTP scaled object. It looks a lot like the scaled object that we saw in the slide, right? It's got the basic Kubernetes YAML portions here, name and namespace. The spec is like a kind of a combination of an ingress controller almost because of the host portion, but it has this familiar scale target ref section here. And so this scale target ref, it tells us, it's a deployment. We're looking for a deployment name front end of using apps v1 version. And it also includes the service that deployment is going to be backed by. And then we have our number of replicas, min, 0, max 10. Remember, you can't scale down to 0 with an HPA. So we're going to start off at 0 here. And then target pending request is how many requests have to, what it sounds like, how many requests have to be pending in order to start scaling up. And scale down period, you don't have to specify, but I set it to 60 because I wanted to show them coming down too. And without that, it would take 5 minutes, just like everything, just like the basic demo pods. And actually, just to show you the basic demo pods, I'm no longer popular. Just regular old Stevie again. So that's sad. So what we're going to do, so in this boutique namespace, right, there's no HPA. And we have one pod of the front end running. So we're going to apply that manifest that I have down there, boutique scale.yaml. And a couple of things are going to happen. One, we're going to create this HTTP scaled object called boutique. Right, so we'll go in there and we will see, here's the spec, here's the target. I think this is a deprecated field that is going to be removed eventually, but it's so it's empty because I didn't use it. And then, we see that it is pending creation of our HPA. So if we go look at our HPA, yep. So it's so it created an HPA for us based on the specifications in our HTTP scaled object. Got to put the YAML there. This is what the HPA that KEDA created for us looks like, right? So we have spec max replicas 10, min replicas 1. We have our average value target, and we've got the metric that we're looking for to get that, and then we have the actual object that we're going to be trying to scale.
Yeah, and what I love about this is that metric there, it's pointing at the external metrics API source, and that metric has a unique name associated with this scaled object, but we didn't have to create any of that. We didn't have to manage, we don't have to manage the metric, the external metric server. We don't have to write a query to satisfy that metric. KEDA did that for us under the hood and just pushed it out there into this HPA object. I don't even really have to care about the external metrics API myself, which is great because it's a pain.
Right.
Yeah.
No, good call out. Yes. KEDA took care of all this for you. So you have this HPA now. That KEDA created. So an interesting thing, if we look at the pods again, we'll notice the front end pod that was running is no longer running. Because we deployed that HTTP scaled object, it took over and it scaled that deployment down to 0. So that pod is no longer there, right? Mm-hmm. So I went to Wendy's and I had an incident at Wendy's.
Oh, you're cheating on Five Guys.
Yeah.
Creating new incidents at Wendy's. All right.
A new incident at Wendy's, and now I am in the news again, right? So I'm gonna grab my host name from a window that you can't see, and that's fine. And I'm going to update my script. Just boutique. Didn't have to do all that. All right, so I'm going to update my K6 script, and we're going to do the same thing that we did before, right? We're going to do watch pod HPA, or we can't watch it, but we'll look at it here. And then we'll go over to K6, and we're going to run our deal. I'm actually going to just do pods right now. And you can see immediately.
That was quick.
Yeah, you can see immediately there's front end pods being spun up to deal with my second bout with infamy. So we went from 0 to jinkies a lot. Although this format of watch makes it look like it's probably a lot more than it is. Yeah. But, as you can see, we're spinning up front end pods, and we literally just created this object in KEDA and told it this is what we want. It took care of the rest of it. Just as easy, I think, as using the HPA, but also I was able to scale on something more powerful and maybe more significant for me than CPU or memory, right? I'm scaling on HTTP metrics in this case. But again, with all the scalars that KEDA provides, you could be scaling on Kafka, ActiveMQ, Prometheus. You can even scale on those base resources like CPU. They have a scaler for that as well.
That's awesome.
Yeah.
That's awesome. We do have a question related specifically to this, and I think it's worth addressing. So the question is, the pod is no longer there, meaning that if there's a request, it won't work until the pod is created. And I think it's important to note in this case with the HTTP scaled object, you're actually using an add-on to KEDA, which is the HTTP add-on,
Right.
and it proxies the request and holds it open until the pod comes back up. So that HTTP scaled object, again, is part of an add-on to KEDA. It's a really useful add-on, especially if you want to scale HTTP services to 0. But there are other types of scalars, as Stevie noted, that can scale to 0. And if your scaling metric is something else, like maybe a queue-based system or some other event-driven type of architecture component, you might be okay with no pods running. We scale it up as soon as there's information ready to consume. And so you don't always have to use the HTTP scaled object to scale to 0. It just handles those HTTP specific scale to 0 situations where you need something to proxy the request so you don't get a 503 or a 504 before you spin up the pod.
Yeah. And as you can see, I finished doing my, my fame was even more fleeting this time. And the front end is gone. No one's hitting my website anymore. I've been forgotten very quickly. So quickly.
And
right.
that fame is fleeting.
So yes, so that is a very quick demonstration of KEDA. And like Andy said, yeah, that HTTP scaled object is an add-on. I bet you can't see this tab, can you?
You can't see anything at the moment. I would like to note we are at 7 minutes, and I know we wanted to leave a little room for Q&A.
Yeah.
So if you want to, if there's something you want to wrap up real quick, and then we can jump to Q&A, or?
Good.
All right.
Yeah, let's take some questions.
All right. Well, keep the questions coming. I know we have a few. I think Katie is here. Thank you to help us with the questions. We cannot hear you.
We can't hear you. Sorry.
Sorry about that.
No.
It looks like you were pretty on top of it, Andy, with answering a few questions. We did have an earlier question come in. I'll post it to the screen right now for you.
Yeah, so we did address this one partially, but then there was a follow-up question to it as well. So I'd like to just clarify again. When you're using HPA with when you're using HPA at all in any form, and you're deploying your deployments, your deployment YAML, you need to omit the spec.replicas field. Because if you set that, whenever you deploy that YAML, it will overwrite the desired replicas temporarily, and then the HPA will take back over. So you'll have a brief disruption. And so the spec.replicas field must be omitted anytime you use an HPA, regardless of what's creating that HPA. So even if we're using KEDA, we need to omit that replicas field from the deployment, or the stateful set if we're scaling stateful sets.
any additional questions. It looked like you were really great about answering them on the fly, Andy. So I don't see any.
Yeah, there was one,
There's
I think, based on HPA that was asking if you can scale on metrics other than CPU and memory. I think we kind of covered that with the demo going on, but you can definitely scale on lots of other stuff. It's just there's more complex setup and it doesn't come out of the box.
Right. There's also a question about defining several HPAs with different HPA percentages for different cases.
Yeah, that was an interesting one.
Yeah. I don't know how that works outside of, because you can combine multiple metrics in the same HPA and it will evaluate them, and whichever one I think makes the biggest change is the one that's what it'll scale to. But I don't know if that's the same with actual separate HPA objects.
Yeah, I don't think you'd want to. I think they'd be fighting each other. And I don't think, if you wanted to deploy one at a certain time and then deploy a different threshold at a later time, you could do that. Mm-hmm. But in general, one metric, one threshold, especially with the basic HPA. Now with KEDA, you could have different activation thresholds at which your trigger takes over. So you could have multiple triggers that have different sort of metrics or thresholds that you want to scale on, and then set different activation thresholds. That would be a pretty complex situation. Actually, Stevie showed a little bit of this with the first scaled object that she put up, because that scaled object had two triggers in it. It had a cron trigger, which was designed to scale the deployment up to 1 and then back down to 0 at certain times of day. And then there was a requests metric. Yeah, so this is it. So this one, I'm actually trying. I wrote this one. I think it's funny you grabbed it. I'm trying to write a deployment that will scale down at night because it's a development environment, and then scale back up in the morning. But if somebody wants to use it during the time when it's scaled down, they can send a few requests at it and force it to spin up. And that's why that activation threshold is 0.001, because I want to be able to just generate a little bit of traffic against this pod and then force it to scale up even when we're inside that scaled to 0 window that's in the cron trigger. So this is one example of using multiple triggers with a KEDA scaled object.
Great. And another one came in. I'm going to go ahead and put it on the screen. From Francisco, the configuration of the scaled object seems to be a Prometheus query. Could it be configured to connect with Prometheus alert?
I think the answer to that is no, but at the end of the day, Prometheus alerts are just Prometheus queries. So you could just rewrite the same query into your scaled object. Stevie, does that sound right?
Yeah, I mean, the query, I don't know what it would do specifically with an alert. So, yeah.
Yeah, like you just take the query that drives your alert and use that as your query for your scaled object. I don't think it can connect directly to alerts specifically.
Great. And then an additional question that came from Roy. Can any of these methods help with the right sizing replicas count based on previous baselines?
I'm not sure I quite follow that one. So if I try to dissect that a little bit, right sizing replica count based on previous baselines. So there's a couple of possibilities in this one. One of them could be that we're talking about maybe historical analysis, right? Where we have a pattern of scaling, where we're at 3 p.m. every day, we always scale up because that's the lunch rush or whatever. And so that could be the basis of this question. And I don't think this really necessarily helps with that. That would be more predictive auto scaling type things that you would have to write sort of your own trigger for, or maybe use that cron trigger that I was talking about based on your own analysis, but it wouldn't do the analysis for you. But other than that, most of these things are reactive, right? All of these different triggers are reacting to a specific event that happened. We crossed a threshold of traffic, or our queue filled up, or whatever that trigger is. And so they're very much reactive, not proactive.
Great. And then we have time for one last question from Conrad. Is it possible to scale based on the deployment's resource definitions, or is it better to put this information within the scaled object?
By resource definitions, I assume you mean like what you're putting in for requests and limits with your resources in the deployment spec, for example. And I don't think that's no, I don't think that's a thing you can do.
No, but it is. No, I don't believe so. I think it's important to note that when you set like a basic HPA and you say, I want an average utilization of 30%, right? That's 30% of the CPU request for that container. And so we calculate utilization. The maximum is the actual CPU request that's defined. So the deployment's resource definitions do affect auto-scaling when you are scaling on CPU or memory. So that's an important thing to note.
That's true. Yeah.
Cool.
Well, thank you both, Andy and Stevie, for joining us today and giving such a wonderful presentation to our audience. As a reminder, the webinar recording and the slides will be online later today on our online programs that you can find on community.cncf.io. We look forward to hosting both you, Andy, and you, Stevie, at another future CNCF webinar. Thank you, everyone, for joining. Have a great day.